Okay, great. So I was a delegate from the Inspire COSPAR program of 2024 of the summer, and this is the CubeSat applications workshop. You are currently in the Kuwait University Robotics Society, AI and Robotics Society. So this laboratory is it's a student society where they do robots and they do like all bunch of really cool stuff. So if you're interested in joining CARS in the future, just look out for their social media. So, and thank you for CARS obviously for sponsoring us in the lab where all the equipment is. So we're gonna start. I'm part of the Inspire team. We have Halah and Taleb as well. We have a fourth member, Hamad al-Nusuf, but he's studying in the UK right now, so he can't be with us, unfortunately. But yeah, hopefully you guys enjoy. Overview. So to start, we're going to introduce you to the Inspire COSPAR program, tell you what it's about, what do we do there. We're going to give you an inside look into the COSPAR 1 mission, which is the satellite mission that we worked with at the Laboratory for Atmospheric and Space Physics in Colorado Boulder. Then we're going to talk about the Hex 20, which is over there, by the way. We're going to give you an inside look on it, see what is it, how does it work, what's the subsystems, and what did we do in it. We're going to give you the demo is basically just you seeing it. You cannot touch it, unfortunately, but you can just look at it because it's pretty. And then we're going to have a break because it's going to be a long while, and then we're going to start with the soldering. We're going to introduce you to soldering. What do you do in it? And then we're going to have a soldering activity. Again, if you burn yourselves, live through it, walk it off, but I hope you don't. We have band-aids, but that's on you. Okay, great. So the Inspire COSPAR program, I'm going to give you an overview. So the Inspire is the international satellite program in research and education. Assalamu alaikum. The Inspire COSPAR program, so Inspire is like an institute or a committee that's aspiring or making students get involved into small satellite missions, right? COSPAR is the Committee for Space and Scientific Research. The program itself provides an opportunity for undergraduate and graduate students to get involved in small satellite building, design, testing, and operations. So in the program, it's a 10-week program. Right, so we're talking shahrain, 2 months, 0.3, so 2 months and a half. It's a long program. You get the opportunity to learn more about how to start a satellite mission, how to begin, what do you do, what do you need, what are the requirements, how does a laboratory that is so advanced, that's NASA funded, which is something that they brag about, how do they operate, what's the standard? So in the program, you get an inside look about how to get your hands dirty, basically, if you're interested in getting into the space field. Okay, I thought, okay, great. So this is LASP. I mean, can you guys see? I just realized you cannot see properly, and I'm explaining. My bad. I'm gonna turn off the lights shwaya just for you guys to have a look. Is this okay? Is this okay? Okay. I think that's okay? Yeah? Okay. The light of the projector is like shwaya doesn't work. Or the colors are, it doesn't give it justice. But if you Google LASP, you will find this beautiful image there. That's from Google. This is the Laboratory for Atmospheric and Space Physics. That's in CU Boulder or Colorado Boulder. It's a very incredible laboratory. It's overwhelming shway when you get in, but once you get to know the subsystems and how everyone works, it's like a little beehive where everyone's busy, and it's amazing. Most of the missions at LASP was done in there. We're talking environmental testing, we're talking fabrication, everything has been done there. It's an amazing laboratory, but this isn't the only building. There are like a lot of buildings. This is the main one. This is where we took our lectures, by the way. We had lectures in LASP, so you do get reading material in the program to do self-learning. God, so unprofessional, I'm sorry. Yeah, I'm just gonna mute it. Right, so you do get, I lost track, yeah. You do get reading material in the program. You do get the opportunity to ask the professors about a lot of things. If you have any questions, there are office hours, so we respect their time. But yeah, the laboratory in general, it's really amazing. The experience was wonderful. So let's get to know a little bit more about LASP. So LASP, it's the only academic research institute that has sent a mission to space to every planet on the solar system. So LASP is the only institute that has a space mission on every planet. We're talking Mars, Jupiter, Uranus, Neptune, Pluto. No, I'm joking. Pluto is not a planet. تأخرت. Ali, you're late. I'm joking. Okay. Oh, what? I'm sorry, what? Well, I mean, I'm just going to start, like, they're going to have to, it's 5:30 and I want to use the time. Okay, great. So LASP is also an established leader for engineering small satellites. So they are responsible for manufacturing, making the small satellite missions. And you can't see the picture, unfortunately, but can I zoom in? Right. So these are the you know what? For the sake of aesthetic, let's give it justice, shwaya, because it's incredible, actually. Right. So these are all the space missions, the CubeSat or the small satellite missions that the laboratory has done so far. So you have all these missions. This is only for Earth, right? Right. So these are the missions. So we have astrophysics missions, we have Earth science missions, which Kuwait is mostly into, by the way. We have helophysics missions and solar science missions, right? If you look closely, if you give like a little bit of insight here, you're gonna notice that there's a really cool satellite, COSPAR 1. That's the satellite that we worked on in the laboratory, and now it's part of the image, because in the laboratory we have this image but COSPAR is not on it. So this is an Earth science mission, and we're going to get into the details of the mission further, right? So again, laboratory, it has a lot of cool stuff there. It's amazing. Yeah, can you turn on the lights? I'm sorry. Thank you. Just not the whole thing. Okay, thank you. That's fine. Right. Yeah, and these are the missions. So if you're interested in the Inspire COSPAR program, let me just give you a little bit of motivation. This is the Conspire team. The Conspire team, it's COSPAR and Inspire. We joined together, we made this word because we got locked out of the laboratory once and we had to come up with a group chat name. I'm sorry, again, really, it's technicality and I wanna, okay, there we go. Right, so this is the Conspire team. This is us, that's me, that's Halah, that's Taleb over there, right? You get the opportunity to work with a lot of students from different countries and different professions. The program is incredible. So there's Inspire and there's COSPAR. We have two different teams. The Inspire team has been working on a mission, which is Inspire Sat 3, A and B. We don't care about those. We care about the COSPAR team. So this is the COSPAR team. We will get into what COSPAR is and what the team is. So we have students all over. We have from the University of Tuskegee, Alabama. There's KFAS, which is us, the Kuwait Foundation for the Advancement of Science. And we have students from the University of Lima in Peru. And we have students from Taiwan, which is the National Central University. This is us. So the program is incredible. It's 10 weeks, so might as well get to know each other, right? You get tasks, you get put into groups. You are forced to socialize in the program. You are forced to make friends. You are forced to get the job done, even if you're doing it alone, but eventually you will have to deal with the team and the professors and the mentors in the program. So, by the way, whenever Halah and I look at this picture, we get teary because it was an amazing experience. Please, hi. Hello. Yeah, please, have a seat. You're not late, we're just introducing. Right, so the program in general, hopefully this gives you a motivation about just how incredible the experience is. And you get to know your teammates, so you're traveling together. It just so happens that I know Taleb and Halah from my university journey, but realistically speaking, you will have to meet your team in the program. So you do bond with the trauma and being alone, and it's fun. So hopefully you guys, inshallah, if you're interested in applying for the program, you get to live the experience and make it even better than what you think it is. Right, so those are the teams, like I said. Tuskegee, KFAS, which is us. The COSPAR has something called the COSPAR grant, or the engineering grant, where you can apply if you're part of the COSPAR committee, if your country is part of the COSPAR community. They get to send students on their behalf. So University of Lima sends students through COSPAR, and NCU, which is in Taiwan. Some pictures for evidence, you know. They say if you didn't take a picture, it didn't happen. It happened. So this is the laboratory. We worked on the FlatSat. This is us working on the FlatSat, and this is the soldering port. You guys can see it, صح? I'm not tweaking. Okay. So this is the soldering port. This is a PCB, right? This is the communication ports that we had to solder in the program. Yeah. Okay, so we're just gonna do dark mode? Great. So, yeah. These are just some snippet and images. We also got the opportunity in LASP to get into the ground station, which is the first picture right here. We got to see their ground station. Ground station is where they control the satellite. They see the status of the satellite. How is it functioning? Is it healthy? Is it good? Is it operating? So at LASP, they have that, and it's a really nice room. We got to know that. We got to build an antenna in the program, which was fun. Really, physical pain, but it was fun. It was a really nice memory. And this is my colleague Halah testing the FlatSat. So what is COSPAR 1? Let's get into that a bit. In here, we're going to start integrating. Halah, Taleb, and I, we're going to start explaining a few things. So it's not just going to be me yapping for like 3 hours. I'll save you from me for like a couple of minutes. But let me explain to you and introduce to you what COSPAR 1 is. COSPAR 1, which is the Committee of Space Research, it's a space mission that consists of a 3U satellite. So when we say 3U, we're talking 10 by 10 by 30 centimeters, right? So it's like yay big, right? It's a CubeSat, or it's a 3U satellite that has 3 payloads on it. So when I say payload, I mean the devices that are put on the satellite to test whatever data it is that you need for your research. Right? So we have 3 payloads mounted on the satellite. We have the So we have the compact radiation probe sensor, we have the solar spectral sensor, and the earth radiation sensor. These sensors are used to get certain radiations and data for the space mission and your research. Right. Do you have any questions before I begin with the objectives? Yes, please.
So you said LASP. Is it LASP, the people who send these CubeSats?
Yeah, LASP is the Laboratory for Atmospheric and Space Physics.
So they design, they build.
Yeah.
They put this on a rocket, the rocket goes to space.
Yes.
And then they're controlling it down on the...
Yep.
Okay.
Yeah. It's that cool, I know. It sounds weird, when you say it, but like it's that cool. By the way, if you want to turn on the lights for filming, I really don't mind. It's بس ليت واحد I guess الله يعينكم يعني بس عشان الإضاءة مو طفي Can you see? I'm sorry. Okay, just
أول ما يخلص صك لك.
Yeah. أول ما يخلص we're gonna let you. Huh? Yeah, we're good. Yeah.
Thank you all for coming.
This is Jarrah, by the way, from KFAS. Yeah, they're the ones who are arranging the whole thing, so.
Yeah, we'd like to have you all here.
Yeah. Thank you, Jarrah.
Of course.
Okay. Great. So, I'll continue. So, every space mission has an objective. Objective is like when you say, so like, why are we doing this? Right, you're putting a lot of money into the program. You're putting a lot of money into the satellite building and manufacturing and testing. So what's the reason? Why are you even like doing this? Are you just wasting our time? Are you just wasting our resources? No. So we have 2 teams, right? And they always fight. We have scientists and engineers. They're always, together. So the scientists, they tell you, okay, we have scientific missions that we have objectives that we wanna. I'm recording. Okay. Did you say wish? Right. So, thank you. It took me hours. Okay, thank you. Right. So the objectives are, they tell you why we're doing this. Why do you want any? Here's why you should spend money on us. So COSPAR 1's objectives are the following: to measure the radiation dose of the single event upset phenomena, to measure the solar spectral irradiance. By the way, while I'm talking, if you're really curious about any of these, you can Google it or you can ask me later. I'd be happy to answer you. So we measure the solar spectral irradiance, and we measure the Earth's radiation budget, which is consisting of a lot of different components, like the oxygen levels, the green gases, and a whole bunch of other fancy words for Earth and science that I won't really get into. So these are the scientific objectives of the COSPAR 1 mission. This is only the science objectives. There are engineering objectives, but we won't get into until later in the manufacturing process. So you're telling me now, okay, so we have a mission, we have the objectives, so like what's the process الحين؟ يعني انت قاعدين 10 أسابيع, you're doing 10 weeks, like what are we going to do? How is it going to be done? So the genius system engineers at LASP, they have a timeline. It's like a set of requirements that you, or like check boxes that you get to do, like a task, to make sure that you're on track, right? So in the program, we were asked by the general managers and the program managers to reach the PDR phase, which we did, thankfully. So yay for us. If you want to clap, I mean, I don't mind. Right, okay. That was really nice. Clap again. Okay, that's great. So you first start with the concept. So what's your concept of operation? What are you doing, right? You said the requirements. We have levels of requirements I won't get into because that's boring, but we have a set of requirements. Hi, please do sit. So we have a set of requirements that we do, and we were asked to do it. We have level 1, 2, 3, 4. You're all engineers, you know what that is, right? No? Okay, so we have system level requirements, and then we get into low level to level 4, which is component requirements. What resistor, what capacitor, what sort of chip you're going to use, right? So you do that, you get the mission design, the initial design, and شلون شكله, how does it look like, and you get to the technical budgets. I won't get into that, but we have two budgets. We have power and data budgets. So how much power your satellite is taking and how much data you're using, because you're using frequencies, you're taking up a range, right? So you need clearance, you need a budget, you need to tell them, you need to tell the country for which your satellite is related to how much data, or from the frequency you're going to take, how much bandwidth, how much, right? So you have that budget that you need to set. Later on, you get into integration and testing, launch operations, and end of mission. Now, if you're really interested in joining next year, which who's interested in joining for next year? Great, yeah, you too, great. So for next year, you will be doing these. This is the hard part. It's not a joke. It's not even, it's like, this was light work for us, right? It's just set a requirement, tell me how it looks like. Later, you're going to get into environmental testing. So mechanical engineers, you know what that is. You're going to get into system integrations. You're going to get into licensing, fun, government work. And then later, you're going to get into the launch. So the mission's launch is set for summer of 2025, which is next summer. So if you're interested in joining the program, best of luck. We were set into teams, and that's where my colleagues are going to start. We have a team breakdown. So this is the LASP standard, or the laboratory standard of how the teams are going to set. You have program managers, systems engineers, mechanical and thermal. You have communications, electrical. You have ADCS control systems. Really won't get into that for your sake because it's a headache. We have ground stations and communications. And flight software. Your flight software. Yes, you are. Now, for the sake of time, then it's 3 hours, we are going to be explaining to you what we did in the mechanical part, the ground station, and the communication part. We're going to start with my wonderful colleague, Halah. Okay. Floor is yours, honestly, I'm tired. Oh yeah, it doesn't work. They can't see.
As you can see here from the side.
I'll turn off the lights by the way. عادي أطفي مهندس؟ عادي؟ لا عشان بس يشوفون.
As you can see here, this is what the satellite looks like from the outside. This is without any thermal shield either. These are the solar panels. The solar panels are all around the satellite. And then this is the side view of the CubeSat one. You can see all of the components it has. So starting off from the top, we're going to skip the antenna for now. First we have the magnet. The magnet is part of the ADCS system, which, as Shatha said, we're not going to get into detail with that. But the magnet works to orient the satellite. So the ADCS system, or the attitude determination and control system, focuses on how to orient the satellite and keeping the satellite in orbit. So the magnet interferes with Earth's magnetic field and keeps the satellite rotating around its central axis. So the satellite is constantly going to be turning and it's going to be in orbit. It actually has a polar orbit. I don't know if you mentioned it. Right?
No, I didn't.
And then after the magnet, we have brackets. We actually have two brackets. The brackets secure.
Sorry.
The brackets secure all the components of the satellite. So then, first off, we have the battery, which are fed by the solar panels, and then we have the APS. The APS is the electric power supply. The APS is right next to the battery because it manages the power supply and it distributes the power through all the system. And then we have the CDH, or the data handling, and the command and data handling. The CDH and the APS are stacked right on top of each other. This is to prevent a problem we have with the serial communication of the I2C. And then we have the CRP, which is the first payload, which is the compact radiation probe. And then we have the ADS, or the attitude determination system. And then an interference board. The interference board works to block any electromagnetic interference between the ADS and the rest of the payloads. And then we have the ERS, which is the Earth radiation sensor, which is another sensor, one of the payloads. And then we have a bracket to secure the whole thing in place. And then finally we have the transceiver, which is this, and it communicates with the antenna to send and receive signals of the satellite. And then this is another view of the CubeSat, just without the solar panels. So as you can see here, we have apertures. What do we mean by apertures? Are openings in the spacecraft. We have 3 apertures on CubeSat-1. First one is, you cannot see it, but it's for the solar spectral sensor, the first payload, which is this one. And then here we have the compact radiation sensor and the Earth radiation sensor. So on some missions, the payloads, you do not need any apertures. The sensors can just operate inside the flatsat, inside the CubeSat or the CubeSat. But all of these sensors need to look at Earth and the Sun at some point, so we needed to have apertures. And the way they're placed, the reason why they're here is solely for the purpose that this is the space where we have it. Being in that certain position isn't really critical to the mission. So we actually choose these places. And then this is how the antenna looks like when it's deployed. So when you send a satellite into space, it's going to be inside of the rocket. The antenna won't be deployed. So when it goes into space, this is how it's going to look like. And then this is an extended view of the whole structure of the CubeSat-1. And then this is the mass budget. So the mass budget was set by the systems engineers on CubeSat-1. And then we were able to stay within that limit. And then the geometric center of mass, which the camera is actually blocking the numbers, but I don't think it's that important for this lecture. And then moving on to the thermal part of CubeSat-1. So we have 2 requirements for the thermal requirements. The first one is that all components shall remain within their temperature range during nominal operations and during survival mode. So survival mode is sometimes in a CubeSat mission, we need to turn off all non-essential components in order to conserve power. So we need to make sure that all the system remains within the temperature range during the whole operation of the satellite, because we do not want any damage to happen to the components. The second requirement is that all subsystems shall be controlled by the CDH board. So these were the operating temperature ranges that were given by the manufacturers of these components. And then this is the allowable temperature range that we want for CubeSat-1. We just increased 5 degrees Celsius and reduced 5 degrees Celsius just to be safe. And then these are the components' heat loads. So these are the worst case hot duty cycle and the worst case cold duty cycle. What we mean by worst case hot and worst case cold in satellites. Worst case cold, it means when the satellite is facing the sun and it is at its maximum temperature. And then worst case cold is when the satellite is in Earth's shadow and it's very cold. So the duty cycle means when it's going to be on and when it's going to be off. So the CDH and the EPS are the whole brains and operation of the whole satellite. So we cannot turn them off. So they're on 100% of the time. And then these three are the payloads. And as you can see here, in the worst case hot, when they're actually facing the sun, they need to be on because the whole purpose of the mission is to get data for the payloads. So they need to be on. But when it's the worst case cold, there's no sun. The sensor will never look at the sun. So just to conserve power, we turn them off. And then the UHF and the UHF transmitting and receiving, they need to be on, not all the time, and this is set by the link budget by the systems engineers. And then we did initial thermal analysis on the Coastbar 1 design without any thermal shielding. And as you can see here, indicated by the red, and worst case cold and worst case hot steady state, only the battery part of the Coastbar 1 causes issues. It's outside of the temperature range. Here, by the simulation, it was determined that the minimum temperature range for Coastbar 1 is, for the battery to be specific, is minus 12 degrees Celsius and 34.5 degrees Celsius. And if you remember, the allowable range is between 5 and 30. So we need to do some thermal insulation. So we designed two fixtures on top and below the batteries, and then also a cover. And then we ran some simulations between different materials. And we designed the cover and kept the battery between 6 and 29.6, which is in the allowable temperature range. And if you if you actually join the mission next summer, you're going to be actually building and testing the system because simulation doesn't always turn out to be good. And now with Taleb on communication.
ما اشتغل صح؟
لا يشتغل يمين.
Hello everyone. I'll be covering the communications aspect of our trip. Who here knows why FlatSat or why satellites in general need a comms system? بشوف hands. يعني half of you worked on KuwaitSat. I assume you know why there's a comms system. خلاص ما بتشرحوا لي بس رفعوا ايدكم زين ما تفاعلوا شوي. Okay, we have comms system mainly for two tasks that we need to be done. Receiving the data. The data we'll be receiving is data we collect throughout the mission. So if we have a camera, we'll be receiving the camera data. We also have a comm system so we can send commands to the satellite. Satellite قاعد فوق ما عنده script that's running that's telling it what to do. We have to manually command it. So that's why we need a comm system. الحين الFlatSat is, or at least in low orbit missions, a satellite is 200 to 2,000 kilometers up in the air. How can we communicate with something that far? Any guesses? ماكو أحد يبي يتفاعل إيش دعوة؟ يلا شتا. How do we communicate with a FlatSat this far? محمد. ترى مو غلط. Any other guesses?
Radio signal.
Yes, radio. At least these are the two we covered. Radio or optical systems. The radio is the RF. We're all familiar with it. حتى radio stations. They actually reach the satellites. وهم lasers أحس كانت قطة بس صح. في laser communication systems يكونون optical systems where the satellite beams down lasers. We receive them. بس مشكلة laser systems, they're less popular لأن they require precise aiming at the targets. That's why radio frequency is usually a more common option. Now moving towards our FlatSat itself. Our FlatSat had a kind of makeshift radio. It was kind of built from scratch and the radios are very expensive. إذا مو مبين we chose the RF option of the two options. Radios are kind of expensive for a FlatSat that won't fly. They chose to make something up real quick. They went with a microcontroller and a transceiver. This won't do a radio's job, but it will do the job for a flat sat. So if you have short distance tests, it will do the job. This was how we got it. Two of them, two devices on a proto board. There's the ESP32. Here's a transceiver, and this part here connects to an antenna. This was the schema we were given. 4 connections, غير input والoutput من الساتلايت. But this isn't what we needed. The connections themselves were lackluster, to say the least. They didn't do the job. So we opened up the documentation for the transceiver, and we looked through it. We noticed that there are multiple modes the transceiver can operate in, and you can choose those modes by choosing values inside registers. Who here knows what a register is? Ahmed, can you quickly explain it to me?
It's a very small unit of size.
Yes, it's usually a small physical spot on the device itself that stores the data. And what would happen is when the device itself, the transceiver, is turned on, it would read the register. It would be like, okay, this register has this value, so I'm supposed to operate in this mode. To set these registers, we needed these connections. A ground and a power source just for the transceiver to actually work. I'll skip the clock out and TRX RX clock and jump to SRead and SData. SRead and SData is one of them is for receiving data, reading, and the other is for sending data, SData. There's an S clock. This is an input to the transceiver. That's basically a heartbeat. The clock out will return this heartbeat back to the ESP32. So it's a basically two-way communication of saying, hey, I'm on. The TXRX clock in the mode we chose wasn't actually used for clocks. It was used to send the register data itself. So the register values were sent through TXRX clock. Finally, SLE and CE. CE is a chip enable. So if this value is 0, the device is practically off. The SLE is basically when we write to a register, we don't directly write to the register. This might be a little too complicated, but bear with me. We don't exactly write to the register. There is a middle stage called a latch. This value here, when it's 1, it loads the value from the latch to the register. So basically, we just have to flash it or pulse it for it to load the value from the latch to the register. This is very complicated. I'm hoping you were able to track through. This took us around a week to figure out on its own the connections and what they do. The whole process took around 8 weeks of the 10 weeks. We decided to go with these ports on the ESP32. The reasons there aren't precise reasons. We just, most of them were convenient connections. Some of them, like the clock, were actually specified by the ESP32 itself. So how do we choose to write values to the registers? First of all, we'd open the documentation again. We'd notice that there are 15 registers that we'd have to write to. These registers would decide everything from the frequency we'd run in, how often we send the data, the fluctuation of the data. All these specifics are in these registers. And we'd have a sheet like this. This is register 0, our first register. It will tell you that these 3 values are related to the max out. This value is the UART mode. And reading these, we didn't know what they meant. We went and researched each register and each value. In each register, they all linked back up into the documentation. So we'd go to this register page, go, okay, what's the max out? I'd go to the section for the max out part in the documentation, read about that, and pick one. Practically going through 15 registers, we needed 6 of them. So we decided on 6 values of the 15. The remaining 9 were empty registers. They were used, or they can be used for other use cases. How could we, now then our next part is how we'd get the register values into the ESP32 itself, or into the ADF, sorry, the transceiver. We did that through a protocol called SPI or SPI. Has anyone ever heard of SPI? Yes. It's a serial peripheral interface protocol where you can write to a specific register or write to a peripheral you can write to a specific device. Let's call it that. And it will send the data in a specific way. This part also took another week or two, figuring out what SPI is, how to run it, how to code it. And we hard-coded the 6 register values into the ESP32. So every time you turn on the FlatSat, the ESP32 would turn on and send the data to the ADF. And then the ADF would set up itself and start receiving or transmitting data as required. We've obviously run into a lot of issues considering this took 8 weeks. So we required a few tools to debug what's happening. The first is a logic analyzer. A logic analyzer reads the data through wires. So instead of connecting the ESP32 directly to the ADF, we'd have a small device in the middle that's connected to our laptop. And it'll read the wire and tell us, okay, the wire is currently sending value 11001111. And we check, is that the value we actually want to send? Yeah, that makes sense. Okay. Our next tool was a spectral analyzer. We apparently had it running from week 3 or week 4, but we didn't know it was running because we couldn't actually read the signal. I'd like you to put yourself in my shoes. I'd code something up, I'd click run, and I would wait for something to happen. I'm not sure if the transceiver is working or not. There are no LEDs. There isn't anything. I can only hope that it's sending a signal and try to receive it from somewhere else. We had a small receiver that had a note written on the back side of it that said likely broken or something like that. So we were kind of winging it. Eventually, they showed us a spectral analyzer where you can hook your transceiver straight into the spectral analyzer, and instead of receiving it through air, you can receive it through a wire, and you'd actually see the frequencies you're reading from and the data you're sending through these frequencies. So it's a very useful tool. I think that's all on the communication side of things. If you have any questions, be more than happy. Yes, please.
Your background is also electrical engineering?
No, it's computer engineering.
I figured I could speak in a different language.
Yeah.
I had a question when
Sure.
you were talking about the registers and you spent 8 weeks
Yes.
figuring out all the different registers.
Yes.
Like the manufacturers of that radio frequency device, they don't give you any assistance or support?
They actually create another board where you can plug this into it, and it's a no-code solution. So you just plug the board into another board and hook it up to your laptop. They offer software too, where you can just set the registers manually, but that didn't work because we had to have it hooked up onto the FlatSat directly. So that wasn't a solution we were able to, although we thought that this was the only solution for a decent chunk of time. Any other questions? I'll leave it to the next part, the overview of the ground station with Halah. So much.
Okay, now onto the ground station. So when Taleb actually sends a signal, we need to be able to see it, as he said. So we're going to talk about the implementation of the simple radio and satellite decoder using UHF, and implementation of the ground station to decode the data packets from the FlatSat. Actually, the second part is complicated, so I'm going to give you an overview, but I'm not going to go into details with it. So basically, I'm just going to teach you how to build your own ground station, and we actually have a setup here. So in order to have a ground station, you have hardware requirements and software requirements. Starting with the hardware requirements, the first one is an RTL SDR, which is a software-defined radio, which is this thing, the small USB. This just plugs into your computer and it picks up signals. So it's basically reads the signals and it turns them, it digitalizes them for the computer to read. You also obviously need an antenna. This is what picks up the signal. This actually does have a small antenna, but if you want to track satellites, you need a bigger antenna. And then we have a low noise amplifier, and you need a laptop. As for the software components, you need the Conda cross. We actually use the radio Conda. Radio Conda is used to decode the data once you actually receive it. And then we have the GNU radio. This is to manipulate the signal. And then the SDR++, or the software-defined radio program. This is to adjust the frequency and actually read the data being sent by the satellites, the data packets. We have gpredict. Gpredict accounts for the Doppler shift. As you have a satellite, if it's passing by you, the frequencies actually does not stay the same, it changes. So gpredict accounts for that correction and it changes it. And then we have a detector app. We literally just installed this, a random app, just to see the angle of the elevation of the satellite. So this is what the SDR++ looks like. It's just a simple software. Here at top you can read the frequency. You can set it manually or gpredict can set it for you. And then you can select the source on top. We use the SDR++ USB. And then you can change this to your liking. And then we have gpredict. This is what gpredict looks like. If you go into this website or this app once you download it, by the way, all of this is open source. You can literally do this at home. Everything here we actually bought off of Amazon. You can track satellites with the comfort of your own home. Here you add different satellites. So LASP, they have 2 satellites in orbit, or 2 CubeSats, Serbi and Qt. We actually added them here. And this lets you know when the satellite is passing by your station. Here I have it set to Kuwait, and then back at LASP we had it set to Colorado. So you basically open the software, you open gpredict, and then you just click track, engage on whatever satellite you want, and it just tracks it for you. All you need to do is go outside, grab your antenna. You literally just point it up. So that with the app you have on your phone, you can see where is the satellite, and then you just aim it, and then you have to actually remove it. It's a very simple process, and then you get to see the data packets sent here on SDR++, and you can press record, and then you can decode them later. So like this, we have the Qt mission was passing over LASP. We have the whole setup. We brought our laptop, we brought the antenna, we just pointed up. And this is the app we used to actually precisely track the satellite, and then we just decoded the data packets. You can have the data packets, but most of these are encrypted. So these satellites have critical information. They are scientific missions, so not anyone can just see the data and can read the data. But this is an amateur way to actually read them and send them. And people like LASP and even NASA, some satellites, especially when they initially launch, they want you to actually record these data packets and send it to them. These will be helpful because they don't have ground stations all over the world. So if you just tell people to just track our satellite and send them, they actually really want to. Like back at LASP, we tracked Qt and we sent it to the actual people who made Qt, and they were able to decode the data packets. So this is the first way, which is the UHF antenna, the SDR++, and then the actual software. And then there's another way. This is used to manipulate the signal and send through the FlatSat. I'm just going to show you what we did at LASP, but I'm not going to get into detail. So we have 3 stages. We have the RF stage, or the radio frequency stage, the IF stage, the intermediate frequency, and then the BB stage, or the baseband stage. So here, the baseband stage, which is the signal at its, like without any modulation, and then the IF stage, or the intermediate in the middle, and then the RF stage. This is very complicated, but back at LASP we had to design the whole process to be able to send signals and receive signals using the FlatSat. And now, since we're talking about the FlatSat way too much, now Shatha was going to explain to you in details about it.
Thank you, Halah. You can turn on the lights if you want. This won't take long. So we've been talking about the Hex 20 FlatSat. We've been bragging about it. People have seen pictures, but let's get into it, right? Like, what is it? Why is it so impressive, and why do people pay so much money on it? And by the way, I'm going to ask you a question later, and whoever gets it right, I don't know, you get free coffee, I guess. Right, so this is the Hex 20 FlatSat. Hex 20 is a company that is specialized in manufacturing such FlatSats. A FlatSat is a test bed, right? So you put your payload or your device, you have this sensor, right? This sensor is going to go on a satellite. But before you put it on the satellite, you want to be like, okay, but like, does it work? Does it give me the data that I need, right? So how do I make sure that I'm getting the right amount of data? Am I getting the right amount, the measurements, right? You put it on a FlatSat, which is a flat satellite. So it's a satellite, but it's deconstructed. So you can see all the equipment. Right, so you can see all the components of a FlatSat or a satellite, right? We use this to test our payloads, and we make our space missions before you put it on the satellite, because the minute it's on, it cannot go off. You know, you want to take it off, you're gonna lose all your money. It's a waste of time, and if it doesn't work, you know, the laboratory would go bankrupt, and NASA would go bankrupt, and you'd get nothing done, right? So the FlatSat is used to make sure, double checking that your system works fine, right? So theoretically speaking, when you're done with this, because this is not an engineering FlatSat, this is a flight-ready FlatSat, right? This one is a flight-ready one. We'll see in a minute, because we're going to have a demo for you. This, when you're done, you can take these off, right? And you stack them up, and you put it into the satellite. So the good thing about this FlatSat is that you can use the boards on there for your space mission. So let's get into the components. Let me just show you what each one is. Okay, great. So starting with number one, this is a battery pack. So usually you have batteries to operate it, or as you can see here, we have a DC power supply instead of the batteries. So in the lab, we use a DC power supply. Later, you can use batteries to operate it, right? Next, we have an EPS board, or an electric power supply board. This provides the power for your system, right? So you can tell there are like eight squares in the FlatSat, right? The third one is a CDH. CDH board is called Command and Data Handling Port. So this is like the brains of the operation. This is where all the fun little thinking process happens. This is where you can tell that, okay, my system is working, or okay, this is like your processor, basically, right? Next, we have a comms port, or the communication port, which Taleb explained to you. How does it work? You can get creative here. Like the people at LASP, we got an ESP32 and an ADF transceiver, but the year before, the UAE students had a different communications port. So communications is based on your specifications, what you want for your space mission. So this is a communications port. We have empty slots right here. This is called spare boards. You can put your payloads wherever, and you have here like a proto board. This is where you test your payload. You put it here, you connect it to this. I'll show you in a minute. And then you start testing it, right? So what we did in LASP, we had one payload to test and to run, which is the payload from the university in Taiwan, NCU, which is the CRP, or the Compact Radiation Probe payload, that measures the solar spectral irradiance, which is basically radiation from the sun, right? So this is their payload, very confidential. No one was to touch it, no one was to smell it, no one was to be near it. If you sneeze on it, might as well, I don't know, go to jail, I guess. But yeah, this is the payload that they tested in the laboratory. The electrical engineering department, or the sector, had to solder and to make a harness for the payload and connect it to the CDH port. So you connect the FlatSat, you connect the payload to your FlatSat, right? You have a USB cable that connects to your laptop. It uses Cosmos, which is a software that they use to make sure that your data is working. This is basically like your mirror, like you open the door, see what's in there. This is like the living room. if you think about it. You know, you can see, okay, there's a chair, there's a table, it's working, I have my data. This Cosmos software is where you see it. So this is what we did at LASP. The process here was, it didn't take long, but the harnessing part, which is basically, it's like creating, it's like I give you like a device, right? And you're required to use soldering, which we're gonna do today, to create like a bridge for you, for the wires, for you to be able to connect it to the FlatSat. So that's what we did in the program. Fun, but you know, it took a lot of time. But the Taiwan team was incredible. They did it really fast. They're like really advanced and they're very smart. So, are you ready for the demo? The demo, now here's the thing about the demo. I need you all, please, to get up and, or do you want to do, you know, any bunch, like for the sake of space? Let's do it for the sake of space because I don't want to, what? Let's do half. Let's start with you guys, please, if you will, like, follow me. Right. So, that's it. Is it okay with you guys? I'll do just half, just to make, you know, for the sake of space. Right. I mean, where's my team? Taleb, Halah. I mean, if you guys want to come. Hi. You might want to like help me out because I'm gonna butcher this in a way. Okay. Huh? I still didn't ask. I'll ask at the end. No, don't tell them. Right. So I mean, yeah. Let's.
I'm in the way.
No, it's fine. I just want to like show them. Right. So this is your FlatSat. Okay. You start operating it. I'm gonna operate it. بس بشبه. I'm just gonna turn it on. Because you need more equipment for it to actually start, right? So this is a DC power supply, right? You use it to operate the FlatSat. You turn it on, 18 volts, 0.02 amperes. It's going to withdraw 3.6 watts. For electrical engineers, you get what that is. For the rest, you don't need to know. Yeah, this is without the payloads, right? So you're going to have your power supply, never turn this off. When you're going to apply for LASP, you never turn this off. You're going to start. We're going to have here 3 switches into the FlatSat, right? We have an RBF. Does anyone know what RBF is? Remove before flight. So you do this first, twice, 1, 2, right? And then you do deployment switches, 1, 2, right? And that's where, do you hear it? Okay, this is the communications port.
By the way, the LED is a very big deal because
yeah,
they
okay.
didn't used to work.
Yeah, fun fact about these, when we got the FlatSat, these didn't work for us. So team and I basically had the mission of talking to X20 and be like, guys, this is not working for us. I had to troubleshoot it myself. So this took me 2 weeks, this little tiny thing. But anyways, so this is an indicator that what's working for you is the following. You have the power antenna, you have solar panel 1 and 2, right? Right, so if you come closer, you can come closer, it's fine, you can breathe here, it's fine. No, it's fine, I'm not gonna jail you. Right, so you're gonna have, this is the battery port right here. Looking at it alone, it looks so simple, right? But it's so intricate. We're gonna talk about the price in a bit, you know? This is your EPS, so your electric power supply. This is your CDH, right? This is your brain. You have a chip here.
You're wearing gloves.
Yeah, I have to wear gloves. Yeah, I can't. Yeah.
I was about to ask.
Yeah. Yeah, I need.
We're not
The reason I didn't operate is because we need ESD bracelets and we need gloves and we need. Yeah, so I can't touch it. If I touch it, you know, I'm gonna. Right. I'm gonna contaminate this. Really, I'm not gonna die. This is gonna die. Exactly. Yeah. So I'm not important. This is more important. Oh yeah, you don't know what we did there. You know, we're like literally. Right. So this is the communications port. As you can see, this is the ESP32. You see that voice? This is the frequency that's getting sent because it's loud. It does it have a problem? Does it have a problem?
The noise is coming from the microcontroller.
Microcontroller, yeah, the ESP32. So if we remove it, you know, nothing's gonna happen. This is your transceiver. It's connected to the antenna. This antenna is gonna send the frequency. Now using the thing that Halah showed you, SDR, the software, you can get the signal that's getting sent. That's what we did at LASP. Now the reason we didn't do that yet is because the antenna itself يبي لها بعد كم شيء to connect it, so we didn't have time today, unfortunately.
Sending the payload data.
Yeah, and it's sending another type of data that we still didn't catch.
We don't have payloads.
Yeah, so how do we connect it to the computer is the following. You have Flash Pro, look it up, I'm not going to get into it, but like this Flash Pro, you connect it to the FlatSat, you have a USB cable, right? You put it in with Cosmos, so when you send data here, you can tell, you can see on your software that, okay, data's changing, the power is getting drawn out, you know, everything's working. Now if you're going to put a payload, you put it here or here, test it out, you connect it to the CDH port, right? And then you start doing your work on Cosmos على الكمبيوتر. USB, you can see what you're doing. Cosmos, the fun of it, you can create commands, so you can add commands into. It's not going to explode. Oh, does it annoy you? I'm sorry. I'm sorry. I'm going to turn it off. Right. So to turn it off, you do deployment first, and then RBF. RBF آخر شيء بس أول شيء تنبط. You know. Okay. This never turns off. You can't do. If we do this, it's over. It's going to burn. Right? And we're going to burn you with it. بس. Okay. So yeah, if you can't see.
المفروض نسمع من برا ترى حيل مزعج.
Yeah. So this is the FlatSat. You want to take a closer look? You want to take a picture? Up to you. Yeah. Any questions?
ليش اسمها مطفي؟
Huh?
إذا طفيت الدي سي بوكس إيش راح يصير؟
No. This never turns off.
إيش راح تسوون لما خلاص تخلص؟
Yeah, exactly. Yeah, I can turn it off. I can remove the wires and turn it off. بس إنه
every time you turn them off and on كل شيء يتغير.
yeah, it's like it's resetting.
الباور سبلايز نفسهم كانوا subject to
Overcurrent.
shooting out the power on يعني when you turn it on
شي 18 شي.
قبل it initializes it shoots
the high voltage. So it's gonna burn up.
حرقوا
مرة قبل flat a device power supply. No.
حرقوا شيء
Yeah.
محترم.
Yeah, there was an incident that, you know, because of this it got burnt up, so we're making sure to be very careful when we touch this.
إحنا بنشيلون إيش راح تسوون هذا النص؟
لا الحين now I can easily either remove it, but for the sake of in LASP like I said, the power supplies you see it overshoot, so every time they turn it on and off it's gonna فهمت. It's like you're sending current sending آخر شيء but in LASP قالوا لنا عشان لا تصير المشكلة let's keep it on لأن اللي قبلنا انحرق مو إحنا. Yeah, so they were just making clear. Now I'm just giving you safety procedures. When you're working in a lab, you have to go with the safety procedures, because if you don't, yes. No, بدون. You can purchase them. ترى كل هذا commercial off the shelf. Yeah, but that's why we're connected into a power supply right now, because we didn't have the batteries. Anyway, yeah. في شيء. This is a FlatSat. This doesn't go there. So you can just switch the batteries. شنها لعبة. لا. شنها لعبة. If it doesn't work out, just remove it.
After switching off all the three buttons.
Yeah.
Can you switch off
Yes. You turn this off. You remove the wire. You turn this off. You plug it out. Okay. So when you're operating it, you plug it in. You put the wires. Turn it on. Okay. Any more questions? Yeah, we should. That's your job, KFAS. Yeah. Any questions? Great. So get in there. Let's get the other team in.
Thank you.
You're welcome. Right. So, second half. Please. Yeah, please. حياكم. Right.
صراحة بيتنا؟
ايه احسابك.
أنا تعجبني الإجاباتها.
ايه احسابك.
بس يوم تبيع دزك لينك يوم تبيع
دزك لينك. Yeah, please get closer.
أنا دزك لينك بالحالتين ما اللي تبي تسويه.
ايه.
انت كنتي بالالكتريكال انجينيرنج سب سيستم ولا؟
Yeah, of course. I was. The good thing about LASP, you get to choose to be in more than one subsystem. I was in 6. Yeah. Minimum 3. They told us maximum you can. Maximum 3. You can't be in more. But we were like, we want to do 6. Anyways, okay. Now let's start. So this is the FlatSat. Okay. What am I going to start with? Right. So as you can tell, these are all commercial off the shelf, so you can get them from anywhere online. They're very simple, and we're going to talk about the price in a bit. It's going to shock you. But anyways, so to operate it, we have the DC power supply, right? 18 volts, 0.02 amperes. It's going to withdraw 3.6 watts of power when you operate it. So it's connected, right? When you connect it, we have 3 switches. You can't see it. You want to come here a bit. Okay, so we have 3 switches. We have RBF deployment switches, right? Does anyone know what RBF is?
Release before flight.
No, remove before flight. Close one though. So remove before flight. You start with this 1, 2 latches. Deployment 1, deployment 2, and then you're gonna see. You hear that? Right. We're gonna talk about that in a minute. So you're gonna see those LED lights. You have the antennas. It's on. You have the solar panels, they're on, and you have the power that's on. This is always going to be on because the power supply never turns off. We never turn this off for safety reasons, right? We don't want this to explode. I feel like if I touch it more, it's going to... Right, so please come closer just a bit because you can't really see it. I mean, I can't do this for you. Right, so you have the battery. I can't touch it. I don't want to touch it. I'm traumatized. Yeah. So you have the battery pack right here. So if we have batteries, this gets removed. You can just operate it right on, right? Yeah? Oh, sorry. Yeah, you can hold it just for a second. We have the EPS board, which is the electric power supply. CDH, which is the command and data handling. This is the brains. So when you have your payload, you connect it right here, and then you can tell using the USB. I'll talk about that in a minute. You see it. You connect it to Cosmos. This is the comms. This is where the voice is coming from, right? It's coming from this microcontroller, which is the ESP32. This is the frequency. So I'll turn it off now for your sake because it's really annoying, right? So when you turn it off, you do deployments and then you do RBF, right? Okay, so let's say that it's connected and we're operating. We want to see the signal. What do? We using Flash Pro. And what is this called? The نسيت UART, the UART cable. So you have a Flash Pro and UART cable, right? And you connect it to a USB. You connect this to your computer, to Cosmos, and you get to see the telemetry data or your data that's being sent and exchanged, and you can play with the data. Good thing about Cosmos is you can add commands into it. So let's say you have a payload, right? And you want to see, is the scientific mission الفلانية or the radiation الفلاني, is it getting sent? The good thing about Cosmos, you can add commands into it. So you can get into the system. You need a computer engineer for that and a software engineer to get into there and be like, okay, I want to add some commands to make sure that my data is present and I can see it changing throughout the mission. So after we're done, we turn it off. Now turning it off, you turn these off like I said, then you remove this, and then you turn this off, and then you plug it out. So when you want to power it on, you put it on, you turn this on, you put it on, you put the wires in, then you turn this on, then you turn this on. So it's like a reverse, forward, reverse kind of situation. So yeah, that's, if you want to get a closer look, please do. Come on, don't be shy. It's not gonna, nothing's gonna happen.
واحد اللي كان من
شنو؟ ايه شنو؟
اللي مو ممكن اللي كان حي confidential.
Oh no, it's not with, it's
Okay.
there. Yeah.
Okay.
Yeah. So Hex 20, when they made these for us, the communications port, like Taleb explained, the communications port had an issue. It wasn't to the correct specifications that we wanted. So what we did in LASP, we removed this, right? We looked at the circuitry at the back, which I'm going to show you in a bit in the soldering activity, and we had to retrace everything back and reconnect everything and desolder and solder the connections again. Now here's another fun fact. This proto board had an issue with from Hex 20, so what we had to do was remove the whole thing and put, you see the green one, this big green thing, right? We had to put a new one, so this is the new one that we put. So we have to remove everything. We have to put it back in. Because there was a problem. It's شوية more advanced. There's something called I2C. So it was creating like a short throughout the whole thing. It was like so much load. Every 15 minutes it used to disconnect.
It was basically overwhelming the system.
it's overwhelming the system. So every time we turned it on, after 15 minutes, it would turn off. So what does that mean? You can't do any testing. You can't do any testing on a payload. Payloads usually take 1 hour, 2 hours to operate. If it's going to turn off every 15 minutes, like what are you going to do with 15 minutes? Absolutely nothing, right? And you're going to have to repeat the process all over again. So we had to replace the boards, and that's what we did. No.
Mainly I2C causing noise.
It was causing noise, and the noise was, the watchdog circuit would just, so it would, there's something called watchdog. Look it up. It's a fun concept, right? So this is the flat set. Any questions? By the way, just so you know, we have user manuals throughout, so we did a lot of reading. So we're not that smart.
So how did you guys know that switching the boards is fix the problem? Did you read it in the manual?
Yeah, we read. Actually, the program manager told us there's a problem with I2C, and he hates I2C, and it's causing the problem. Yeah, and we also communicated with Hex 20 themselves. I did that. Taleb did that. We had the meeting. You didn't do that? I did that. We bonded. It was fun, but we had to get things done, and that's what we did. Also, the LEDs, we also had a problem with it in the laboratory, and I fixed that. It took me like a week, but it's working. When we operated it, ما كان قاعد يشب. And the other teams, it used to light up. So I was jealous. I was like, why did we get the crappy flat sat? We want to fix ours, so we did that. So yeah, any questions?
How much would it cost to buy it?
Yeah, okay, let's talk about that. Right. So so let's talk about this. Hey guys. Hi. Please sit. Right. مو مشكلة تمام. So هلا. اي
هذا
لا في ورشة.
اوكي انا قاعد.
براحتك. مو مشكلة. محمد يبي يصلي I think. Right. So you saw the flat set. Was it fun? Is it nice? I mean, here's the thing. The plan was actually to open up and demonstrate the communications port for you. But we do have a little bit of issues with the code and the antenna. So,
Whose fault?
My fault. لا it's not an issue. Yeah, but because who I'm sorry. انت سكرته? Why? I just said safety concerns يا أخي. فشلتنا. Okay, but كيفك? Hey, listen, we're talking about price right now. You're paying it. Right, so like we said, it's commercial off-the-shelf components. So what does that mean? It's cheap. You can find it anywhere online. So what is the most expensive part in such a device? Can anyone guess? No. Guess. Huh? No. It's an ESP32. Chem. نص دينار. So what's the most expensive part of such a system? Can anyone guess? No. Come on, tell me. No. What? No. Huh? No. The most expensive part about such a device is the software that it uses and the building of it. So if you accumulate all the numbers here, crunch it up, it's not going to reach $500, $600 tops. With the software, this thing, which KFAS paid for, by the way, costs $25,000.
Have to be paid for licensing or X20?
Sure, but that's not the impressive part. When I say software, they're gonna be like, "What? Software? 25?" Makes it, marketing. Yeah. Now the fun part is when we discovered the price. Taleb told KFAS, "I do it for you for $24,000, no problem." So yeah, it's $25,000. 25 or 250,000? 25,000? $25,000 without shipping. Without shipping fees. Shipping alone costs a lot. So yeah, that's why it's expensive. That's why That's why you're not, you can't sneeze, you can't breathe next to it. It's too much. Now, we didn't know the price until 10 weeks after. So what we did in the laboratory was, we kept, fidgeting with it and playing with it like it's a, it's like you have a Rolls Royce and you just put a kid in there and you're like, here, drive it up, It's that crazy, right? So yeah, anyways, really expensive, really intricate. It's an advanced level. So when you go to LASP next summer, inshallah, you will deal with the flat sat in there. You won't deal with this one. It's the same one, and I fixed it. We fixed it. It's operating fine. So yeah, so you will see it there, because they made 4. This is ours. Team Taiwan didn't get one, but that's up to them, right? So any questions? And by the way, Taleb, I want you just to come for just 1 second. So if you have any questions, feel free to ask Taleb. So far what we talked about was the program, the Hex 20, and the COSPAR 1 mission. Does anyone have any question? Yeah. Yes.
Is it safe to hack
The antenna? Yeah. This is just a Yagi antenna. It's just no. This is like for kids. It's nothing. You get a radio from it. Radio. تعرفينه بالسيارة. FM AM. Yeah. You just put it outside. You're like, okay. This is like one way. So you have to do this, by the way. Right. But this is very, very safe. The actual one, the big advanced one, اللي فوق المباني. Yeah, of course. You don't touch that. You're a KuwaitSat. You have your own ground station in the north building. Yeah, but this one's like, this is like a child's toy.
Was it fun or لا؟
Hey.
The last experience?
Yes.
منو أكثر واحد ونسك؟
The fact that you have to think it is insulting to me.
He's liking them.
He's liking them. قول أمال وسيب نفسك.
لا خلينا نقول اللي اي واحد نسي مو موجود هنا بس I leave it up to interpretation.
Right. Yeah, anyone had a question? Yeah.
اوكي سؤال شوي يعني شوي
Yeah.
طبعا الكل عنده انتجرال بروجكت بس منو تتوقعون الكمبيوتر الثلاثه كان عنده اوكي في شخص رابع اسمه وولف عليه
Yeah.
منو كان عنده the most challenging subsystem من الحين the most challenging subsystem in terms of يعني challenging requirements or most critical outputs.
Okay, so you're asking who had the most difficult job.
كانت in 6 subsystems ما يصير تقول ولا شيء هي اكثر
مو personal choice.
Okay, I'll tell you.
لا يعني مو انه مثلا
Will you wait for my answer?
مكتوب ask طالب ما يصير تجاوبين ما
Okay, يلا answer.
شذا she was in 6 subsystems.
I'll tell you why. Listen, handling 4 children and like yeah,
وين الرابع؟
me.
Okay.
Right, and on top of that, being a program manager, because I was in the program management, and being, it's tough. I'm a single mother with like a lot of kids to handle.
your outputs.
Right, so I'll be professional with you. Jokes aside, I'm serious. Like, okay. So it's a fun workshop. Like, don't take anything seriously. Do, but like, me. Right, so we have these subsystems, right? For the program, COSPAR 1, we did not need an ADCS control system because COSPAR 1 takes radiation, right? So radiation is omnidirectional, so you don't need to point your satellite in a certain direction to get data. So COSPAR 1 did not need that, so we can scratch that. Project management, you have to like make sure that everyone's working. It's like being a team leader. You need skills for that. To me, it's light work, but like, yeah, systems, they have to put the budgeting. So you have to put the technical budget, power budget, link budget, delta V or propulsion budgeting. So they had some hefty work شوي. Mechanical and thermal, that's literally a bit where they actually had to do most of the work because it was simulations. You can tell they used ANSYS, they used SolidWorks, they had to make things. It wasn't from scratch though, because the people or the science team sent them, or the companies, they sent them their 3D designs. So they just had to open the file, but the integration of the whole system together was a bit challenging for them. And the thermal analysis, flight software, they also had a little bit of hefty work because they had to program everything and they have to make sure to add commands to figure out how to do that. Ground station, it was fun. Comms, you know what? Comms was the most difficult one. So Taleb had the most difficult job in a way because we didn't know what we were doing. We barely had any data. The data sheet was so old that, you know, even the guy that was supposed to help us, he was on vacation for like 3 weeks, and when he came back, it's like, oh, our Lord and Savior. So it was a bit, this was hard because we didn't know what to do, right? But we figured it out. I mean, we know what to do, but like we didn't know if what we were doing was correct. Yeah, so we needed some guidance and it was a bit tough. Electrical was fine. So I don't know what your question is. Overall, it was, each task had a different level of difficulty. So it basically depends on you and what you can handle and what you can't. You're strong enough. You'll be fine. If that's what you want to know.
I mean, I worked on stuff.
Yeah.
بس ما نشتغل بالCubeSat.
إيه.
It was يعني lunar based. فكان أكيد إن البرسبكتيف غير. For my end يعني كان structure subsystem أصعب شيء لأن كل كان معتمد عليه وأنا أعتمد عليه.
Yeah.
بس أكيد الCubeSat راح يكون غير.
Yeah. Let me tell you. The good thing about the program is you get the responsibility of the task that you're assigned. So inshallah you're in, I don't know, whatever subsystem. It's your job. You have that responsibility regardless of what subsystem you're in. Right? For me, for example, electrical, I had to take on the soldering process. So if I didn't know how to solder, the other subsystems and the teams that were with me, the other countries that I was dealing with, they had to, you know, if I didn't finish the task, it's my responsibility. Okay, Shatha didn't solder the communications ports, so none of the flat sats is going to work. And when they take it home to the, you know, to whatever, they can't operate it. So each one of them had their own level of difficulty, their own responsibility. So if you're in the program, even if you're not the leader of the subsystem, you will have a task. You will have to get it done, and there are people who help out. The good thing about the program, to be honest, you see all these, it's amazing. The Inspire team had been working on the project for 3 years. The Inspire Sat program, they've already been working on it for 3 years. They had experience. It's those guys, right? So we can ask them. We can ask the mentors. We can ask the professors that were in the laboratory. So you get, the space community is so welcoming in LASP that to the extent that, you know, it's really fun. It's difficult, but it's fun, and you learn, and you're a grown-up, right? So you go back home, you don't just have fun. No, you have reading to do. You have, right? So just so you know, by the way, like program management, right? They're done. They're just not going to be like, yeah, you did the job. No, there's a mid-program and final program review to the professors and the TAs and the mentors there, where you have to show them the progress. So there's that pressure as well. You have to make the progress to show them what you did, right? So if you didn't finish in the mid-program review, you have the final to get it done. And if you didn't do it in the final, you're not coming back next year and you're going to get kicked out. At least that's what I think, you know. Right? No? Oh, come on. I'll kick them out. So yeah. So that's I hope I answered your question. Yeah? Great. Any other questions before we take our, yeah.
My question is, the first 10 weeks
Yeah.
you went to this year,
Yeah.
You just designed the satellite itself.
Yeah.
So in the next 10 weeks, you just make this, you build that yourself?
Yeah, it's gonna be like you're gonna get the equipment, you're gonna start doing some integrations, and you're gonna start doing environmental testing. So this needs mostly mechanical, electrical, and computer engineers, where you will, okay, it's like you have like a little, you know, cupcake and you put it in the oven. The cupcake is the flat sat. You put it in a TVAC or a thermal vacuum chamber, where you do thermal testing. So you did the simulation. We did the simulation of it, right? This is simulation. It's just a software. You just put it in, 3D design, whatever. You will do the actual thing in the program. You'll put it in there and you're gonna be like, okay, right? So this is environmental testing. You have TVAC, you have other environmental testing operations. You will have system integration. You will have to deal with the other payloads, because in the program we only did with one. You have two more, because we have 3 payloads in the mission, right? You will also have anomaly detecting. System testing, yeah. Verification, validation, yeah. So you will, This is where you will get your hands dirty in the next 10 weeks. So it needs a level of expertise. It needs seriousness. It's not a vacation, right? It's a really good task to get into. Did I answer your question? Okay. Any other questions? Yeah.
For mechanical engineers, the primary kind of work you're doing is modeling, or
In the beginning of the program, yeah, because we were.
okay.
You get in, you have no idea what space is, right? So they're not going to give you, work at TVAC. You're going to be like, okay, let's start small. SolidWorks, great. Let's start with that. ANSYS, let's start with that. You have mentors all over. They're going to be like, hey, let me teach you. Let me give you some reading material. So they did simulations at first. In the next year, they're going to start doing the actual, structural and system analysis. That's what we're going to do. So you're basically going to build that in a way. Yeah, Ali.
Just a quick question.
Yeah.
Regarding the antenna, you experiment with different types of antennas?
Yes.
Or was Yagi the preferred choice?
You mean this one?
Yeah.
Okay, this is like a little game just to show you how to receive a signal and how to, right? The actual, okay, let's say that we do get into building the antenna. Let's say that we do get into, okay, COSPAR is out there, let's start. We will actually built the antenna, right? You're going to start building your antenna. You're going to have to put it out there in the building. And so, I'm sorry, what was your question?
You try experiments with different types?
No, it's based on the specifications. So, I don't think so. I don't know. You know what? I don't know. It's easier, right? Any other questions? Yeah.
Did they teach you about control or how you're going to control the?
This is ADCS control systems. Yeah, I did get the reading material, but because COSPAR 1 does not require an ADCS control. Next mission, maybe COSPAR 2 will need an ADCS control system, so you might want to read about that.
So
Yeah.
For this mission, غالبا إذا عندك مثلا sensor attached to pointing at the sun or عندك camera you need to face it on the earth or anywhere. So you put the ADCS system to point and actually orient the satellite. But we have only 3 payloads and these payloads are all radiation payloads. They just need to measure the radiation, so they don't need to be pointed to. So why put all the money into building an ADS system when we don't need them?
solar panels don't need rotation? Or
No.
oh, only the rotation.
It's going to be all over the satellite.
So no reaction wheels, no nothing. It's
No.
this one.
It's just orbiting around itself and moving, and it's just getting the radiation because radiation. Yeah, you increase the risk of drag. You have drag. You learn more, of course. Yeah. So again, but it's not in this mission. But I mean, hopefully your mission's gonna have an 80-second control. And if you cry about it, only blame yourself for it. So any more questions? Right. So we'll have a 15-minute break because I'm tired. Yeah. And then we're gonna start with soldering, inshallah. Okay. Right, so please eat. We have some juice, we have some coffee.
I require a meeting مع Taleb.
Yeah, okay.
I want to ask about something.
Okay. Now? Okay, Taleb, Halah, please. The girl wants Taleb. Yeah.
By the way, I saw you from the hackathon.
Yeah, so proud of you.
Thank you.
Yeah, what's up?
Okay, فبيسكلي أنا كنت يعني ندفع وأقدم
إيه program.
I backed out last minute لأن شفت إنه والله الصيفي وايد أهم لأن أنا الحين ما تخرجت يعني الصيفي وايد أهم من البروجرام هذا وهم أبوي زفني ليش ما قدمته وكذي بس يعني I got صدق
أخذت الصيفي
بس ما أدري يعني هذا اللي بسأله هل يسوى لأن أوكي I got another opportunity إن اشتركت في Space Station Design Workshop بألمانيا و it was يعني شفتي شلون قاعد تقولين اوكي قعدنا
انت متخرج كنكو
قعدنا شهرين نشتغل وستب باي ستب الحين هذا كله كان ب 1 ويك و يعني كنا نواصل نقعد بالجامعه.
شو تخصصك؟
ميكانيكال.
اي سنه الحين؟
4.
اوكي.
اي فعرفت لي يعني اوكي I've already worked on something like this بس انه
for next year.
this opportunity يعني احس انه
Can I be honest with you? It's a once in a lifetime. It's a once in a lifetime. شوفي ما عادش وحده ولا بحياتها ما قضت صيفي بالجامعه. تخرجتي ب5 سنين. نورمال. شي سكبت صيفي.
انا المفروض اتخرج 4 سنين ونص ما خذيت صيفي الحين بتخرج
كورس الجاي ما تفرق.
بس حلوة.
التخرج المبكر ما حتفرق معك.
It's not مبكر. أنا أوريدي
انت محاولة كنت
لا مو محاولة بس
شوفي let me tell you something. Let me tell you every female I meet says the same thing. أنا متأخرة على شنو؟
Look at it in 2
لا
years.
إيه على شنو؟
You will remember the experience.
One summer will change your life.
I know that's what I saw in Germany لما اشتركت.
Yeah.
It was 1 week but it changed
So
my life.
here's my advice to you. Apply for next year. Don't be a wuss. Do it. Inshallah you get accepted because you're that good. Get in there and thank me later. Apply. Yes. You will thank us later. كهرباء. هذه ما تخرجت للحين. هو كان تخرج وراح أمريكا يعني كان. إيه.
بلا صح لما فزت
إيه. فإتس.
ما أدري.
لا هو.
What's your name? Dalia. Do it.
In my opinion, it's worth it.
It's worth it.
Okay بس إنه it's not يعني مثلا my first experience على شيء كذي.
لا هو صح.
It doesn't matter. No, because next year is going to be advanced level.
لا هم ranking up هالexperience ranking up هالexperiences.
مع الexperience إيه. I mean your LinkedIn page is going to rock.
The connections you're gonna make.
The connections and the networking you're going to do. Like you know Antonio? Right. I know him from LASP.
I knew him before.
Okay. يعني I'm just telling you the connections that you make it's going to be.
إيه السبيس أصلا بروحه صغير فيه.
إيه the space communities yeah. فأنتي don't be afraid. شوفي الصيفي is going to always be there. It's not going to go anywhere. No, not really. كم 6 شنو وحدات؟
6 وحدات.
وحدات ولا كلاسات؟ وحدات؟ اوكي حبيبتي توكلي على الله. لا انا اسهل وراقك من الجامعه الحين.
هذا نص الكورس الاعتيادي يعني.
Yeah.
في اللودو النورمال كورس.
ما
تاخذ صيفتين. انا اخذت كنت 7 وحدات.
لا انا قاعد اقول ان هذا half the load
It's
of a normal
not.
course. Is it
It's
worth missing out on
It's
experience
not.
over half a load of
It's not girl listen take it from
worst
me.
case scenario, you say an extra course. The time you spend during her course بيكون 6 credits فبيكون حيل سهل يعني.
It's nothing believe me. Don't waste it.
Honestly I don't regret اني ما قدمت.
نصيحتي لك صلي استخارة وتوكل على الله.
صراحة قدمي
think
about it
when you get accepted.
think about it لين ما you get accepted.
إيه.
ويوم you get accepted راح تلاحظين انه too late. انا تدبست.
انا قدمت ما
ايه فخلاص.
إيه.
makes sense
إيه.
makes sense.
Yeah. You do it.
ليش جايب اللاسب؟ ليش جايبين اثنينكم اللاسب؟
I was bored at home. I was like, let me up it up شوية. Let me. هل.
عندي أكثر من سؤال.
تفضل.
أول شيء لما ترجعون تبي تبلشون أتمنى تنبهين على شغلة إن اللي بيقدم السنة الجاية لازم يكون طالب ماجستير.
لا مو شرط.
الشروط اللي كانوا حاطينها KFAS إن أنت لازم تكون طالب.
أنا طالبة ماجستير.
الحين أيا كان طالبتي بجامعة الكويت كنت محسوبة على
لا كنت متخرجة.
نبيهم على هالسالفة. الحين أنا أتكلم عن الشروط العامة.
إيه أوكي. لا كان في وايد رسم كان مقدم.
شنو مو لأنه يبي يقدم.
إيه.
بس إنه علشان لا يتورط هذه شغلة.
إيه
الثانية أنت شنو الرول مالك بالضبط كان بالشغل؟
6 roles ماخذة كنت أنا.
زين شنو؟
program management.
زين هذا اللي يهمني.
إيه.
زين سؤال في ريسورسز حق السالفة؟
حق program managing؟ لا.
زين ماكو أي ماتيريال قريتوها أي شيء؟
حق managing the team؟ لا.
ولا زين بروجكت مانجمنت شنو تعيش؟
شنو يعني احنا كان عندنا فور اكزامبل يعني احنا كنا نقطة التواصل بيننا وبين الآمال.
اوكي.
بين الطلبة وبين آمال. اوكي so we'd have criteria. احنا اللي كنا مسؤولين ان نسوي الميد بروجرام برزنتيشن والفاينل بروجرام برزنتيشن. احنا كنا مسؤولين نفهم كل السب سيستم شنو سوى عشان لما آمال يسألنا احنا لازم احنا اللي نجاوب لان احنا اللي نقدم.
هذا كله ما اعطوكم ولا شيء تعلموه؟
لا
بالهواء كان.
اي بالهواء.
لأن أنا كان ببالي إن خلينا نشوف إذا أعطوكم شيء مفيد.
لا it was chilly. وبيني وبينك I was managing the program managers بعد. لأن أنا كنت ومع يعني نفر من كل دولة.
زين.
And I was their boss basically. لهالدرجة كان الموضوع شوي سباحة.
دايس.
حلب الزين.
أنا قاعد أسأل.
ما تقولين لي؟
وليش تقول لي؟
قلت لك تون بالبروجرام كاهو.
زين يعني انا قاعد اسال والله انا قاعد اسال
مو خلصتوا؟
انتم ماكلين حقوقنا انتم شنو هذا؟
احنا ما نسوي.
ايه خلاص احنا قرابه خلاص يعني.
على عيننا وراسنا زين.
ايوه الحركات
ما له علاقه.
شنو خلصتوا؟
خلصنا
شوف شي كات مي اوف.
خلاص مرتك يك ما اقدر ام سوري. ايه يلا ايه
سويتوا انتنا؟
ايه بس احنا ما كنا ندري اننا بنسويها. يوم قالوا لنا باكر اللي وده في راح نسوي انتنا تبون تيون؟ قلنا له ايه بس يعني احنا فوق وبنيناها. ايه it was for another space mission.
ركبتها؟
ايه ركبناها.
مو سويت. اي اوكي
انا مع امال سويت انتنا تيونينج انا حق كوسبار 1.
اوكي
بس it was nothing يعني مو شيء واو.
انتنا تونك مو يعني يكون شيء قبل الانتنا.
ايه exactly. ايه لا we didn't. It was just like a little building thing. شلون؟
والحين شنو
soldering.
شنو السيركت؟
وايد عبيطة. السيركت وايد عبيطة. You'll see. بطن LED وريزستر وبطارية. ايه لأن لا
أنا زعلت إنه it's not the same inspo for the robot اللي عندكم. قال لي it's random نطلع. قاعد أقول له أنت شايف الفيلم؟ يقول لك لا. جايزيني how it looks like him. Because he ends up flying because he was شنو robot and he was like in a graveyard. Then يفتشونه and he flies them over. I need to tell you.
How was it so far?
Great. Enjoying it.
Are you having fun?
جايبينها من هنا صح؟ Because the company when I wired the money كان عندي contact.
Yeah, it's India. Yeah, it's India.
It's the spin-off company that was telling me.
Nasser was the fatura guy since a long time.
Exactly. Oh.
The sticker لا فايدة.
Oh, حيل.
أنا آسف بس I sent it to someone.
Someone عادي هم ناس.
أي ستيكر؟ أنا عندي وايد ستيكرات بسويها على ناصر لأن عندي وايد صور.
أنا صراحة كنت أسوي بس خلاص I broke the barrier إني أمسك نفسي وما أسوي ستيكرات على الناس. I have like stickers من ناس شيء براندم من سوشيال ميديا ألقى صورهم مسوي ستيكرات. I feel so bad بس الدنيا دوارة. Someone has stickers of me somewhere.
Yeah, of course.
لا I create them.
عادي.
إنزين.
لا هذه مو عشان يبطل الباب. لا هذه مو عشان يبطل الباب ويسكره.
شنو عيال عشان يطفي شنو؟
لا عشان لما تكبسه يدز حق ديسكورد حق الممبرز اعضاء اللاب انه مو هذا فشلتني. هذا
حاطين سباي بروجرام.
هو في شيء انت كملي ما احنا ما ندري.
ايه انه يقول حق the members of cars ان the lab is open ولا the lab is closed.
ايه هذا being smart not lazy.
It is.
هو قاعد يقول he's being lazy.
لا لازم تختارين أكثر من شيء. أصلاً كان المفروض.
When did I start the break?
I have no clue.
You want to start at 7:10? ولا 7? يعني in 5 minutes. I don't think 15 minutes pass.
لا لازم اسوي ريكومنديشن.
المشكله
والله انا خليني ساكت انا ترى بس.
هذا ما تدري شنو؟
منو؟
هذا
cars.
opens the door.
ايه اوكي. It's a motor, yeah, I guess.
بما انك مالت كويت ساعات الحين معنا
ايه
ما تشغل فيهم. كم مرة علقنا برا اللاب؟ انتي اول ما حضرتي تعليقة اللاب. اوكي ما
مو هي ما شافت المسخره اللي كنا نعيشها. ترى انا عندي فيديوهات لهم يبطلون الباب قدام اليونيفرستي.
انا عندي كل فيديوهات.
اي يعني يعني انا اذا بسجل
محمد صوت وصوره.
شنو؟
كاميراته.
يقول ان هذا
في لايف هاك هنا عندهم.
كان هو يقول ان انتم كم مرة قدرتوا تبطلون اللاب. فاحنا عندنا مشكلة ان احنا دائما معلقين برا وندور عشان نخش اللاب. فالحين شو نسوي؟ نحط مسطرة عشان نفتح. فقاعد اقول له لو عندنا هذا.
آخر مرة this happened ما كنت أقدر حتى أشيل التليفون. It was really bad.
Or try to eat something. أو شربي عصير. شربتي عصير؟ عصير.
Ritz is salty. This is
من
sweet.
عصير الجوافة؟ اللي قاعد تشرب عصير الجوافة right now. الله يلوع شبت الذوق الخايس. من يشرب عصير الجوافة؟
في a lot of variety. Like كستيلي على the one thing that I actually drink. Sorry. Hi. Guys, افهم.
It's fine. I thought I have questions for you.
Yes, ask.
تعال especially أسئلة ذا problem. That's why I didn't answer. الحين no serious question. الحين أنتوا you went on LASP. You went on LASP. You went to LASP. When you went there, like I'm assuming not everybody has experience with space and generally you went there. Did you learn everything? Like was it clear?
Halah had not.
You were in like
Halah had zero knowledge on space.
I met her.
Taleb had zero knowledge on space. Yeah. Taleb.
I think Madi it was weird. I guess it's fine.
It's not. I love it.
Okay.
Taleb and Halah had zero knowledge in space.
Yeah, I'm like assuming. يعني ما توقعت.
Throughout the program, you have reading material they give you. اقرا get to know.
تفهمون reading material?
Yeah, we're not. Yeah.
حسيت يعني إذا ما شفت
بلا.
But so like even if you knew nothing, you go there and you learn.
Yes, because not only that, you have mentors roaming all around the lab. فانت تشوفين أحد
I
يقرا.
feel like it's not enough.
Actually, it wasn't that much enough. But again, you.
Nothing to like.
بس ترى we're talking like 2 months and a half. It's enough. It's good.
It's enough. I know.
But again, let me tell you something. It also depends on how much you pour into the program. The more you لا في ناس يعني they didn't pour their 100%. They didn't learn much. فهمتي؟
The best of playing bowling.
يعني دشوا وراحوا when it was like إنه whatever ما تعلمنا شيء بس that's because they didn't do anything. They didn't get the initiative. ما قالوا hey what are you doing? Let's learn. Required to? No. The good thing about the lab was
everyone like كل واحد ما بيدري على شيء ثاني شغله.
Yes, that's true.
Don't do it.
Exactly. So we had to. They did it بس إنه they only did that. They ما قالوا باخذ that task.
Okay.
Exactly.
Are you guys rivals with the time?
No, at all.
Become besties?
Yeah, we're all besties, 100%.
Are you sure?
Yes.
I got rival by
No. Inspire team كانوا شوي لأن they're more advanced. CoSpar نفسه إحنا تايوان. لا هم لنا لأن كل شيء confidential صافين تكفى يلا. بس we get it لأن protocol.
Is that the thing I was supposed to touch?
Yeah.
Can I touch?
No. I'm serious, no.
Why is the software 25,000? Like, make it make sense, please.
Yeah, it's like they're making it from scratch. You know, you're building the entire system from scratch.
25,000?
It was like they're building the libraries from scratch. They're building the thing from scratch.
Is it that complex?
Yeah, you should know. It's your major.
I'm not sure what it has to do here. So, like, if I make it complex, I can sell it.
Yes. 100%.
You make it and sell it to you guys.
For 30,000. I have no idea. كلمي ناصر. دكتور ناصر.
Oh, we know him. And then next year, are you going to continue on what happened?
Yeah, suppose, yeah. With the people who are...
Like the first time.
Yeah, CoSpar 1.
Oh, it's so annoying that I know
علوم.
Makes sense.
You've seen him in physics. You've seen him in all the videos, by the way.
Valid.
Yeah.
He's a British guy.
Who's? I have no idea. I'm like, keep talking. I like. Yeah.
لأن أهم إنه it's fine. You're good. Speech.
ما سمعت.
أبغى خطي إنه سمعت تسبيح.
ما سمعت تقولي.
By the way, you're amazing. Love it.
Thank you.
صدق فهمت يعني. Didn't expect it honestly. Didn't know.
Okay, that's good.
شو كنت بقول? Familiar. Like I know it.
You've seen him before. He has a familiar face to him. يعطيك العافية. الحين بنبلش معاك. Right. I think نوزع عليهم ولا نقومهم ياخذون؟ The components ولا نقومهم؟ نوزع؟ Okay. Okay.
One of each?
Yeah, one of each and 2 wires. So 2 wires and one and like you don't have it just either this or this. Yani it's up to you and the resistors.
They're all the same value?
Yes, these are the same value.
They're all the same value.
Yeah.
And one button.
Yeah, and 1 button. You are قاعدة هني. ما قد ادري ترى ترى I'm freezing I'm freezing too by the way I'm freezing too right right
كل شيء اقدر اسويه
okay I think we should start ولا شنو 7 right yeah هلا
هاي جديدة مصورة اليوم حق محاضرة
يا اسبانيا اي اوكي مخي صار حاشا ابو اللاق
بتبوظ منكم السوالف شلون؟
محمد هذا مو
ايش رايكم بالانقاذ بس؟
حلو
من هني ترى انا
ايوه والله يعطيك العافيه
ازدع تعبان شايل على
والله ما كنا راح نكمل الا من
لا بزياده عاد ترى خوش لهم زين محطينكم حجمه زين مكانه زين
ايه قسم الكمبيوتر مضبطين نفسهم ما شاء الله
عباس فيروز خوش واحد
ايه تبارك الرحمن
بس ابرد منه ما
ايه
انا عارفه هلا نصه
ايه قلت لي ايه بس ما شاء الله عليه طبعا having fun really we good
صح انا احس وايد برد اصابعي وايد يعني بارد
لان كانوا مفتوحين الدرايش باي ذا
المفروض تخلي البروده هي التكييف المشكله
اوكي الحين right so if everyone can be seated we're going to start our soldering workshop hello soldering يلا yeah give me mine
المهم
thank you ماني نازله
لن نركع
يلا please have a seat يلا
انا
اوكي بس انت بتسوي soldering though تستعبط خلاص بجيب لك الاكويبمنت بعدين
شو اسمه
ميتنج شنو more important than this
apparently yes
اطلع برا okay right so now we're going to start with the soldering
Does it make the room warmer when you're doing it?
Yeah. I mean, if you burn yourself, hopefully. I know it's cold. Yeah, I don't control the weather, literally. It's a central system, so. You get used to it. Yeah. Halah. No. You have gloves. But I'll explain. ما تبي soldering? Okay. Okay, يلا. Right. So, please, okay, يلا, okay, مو مشكلة. ترى, because I can hear you. Okay. Okay, so we're going to start with soldering. Again, who has soldered before, raise your hand. Great, who has never soldered before, raise your hand. Okay. Yeah, so it won't be long, right? So soldering 101, a little bit of introduction about what soldering is. So soldering is the process of joining components together by melting solder around your components to create a functioning circuit. So we have right. So we have a couple of elements for soldering. So you have the soldering iron, right? You have the solder, you have the component, and you have a circuit board. The components that you connect are either in electrical at least. So you have resistors, LEDs, or light emitting diodes, or a light bulb, basically. Capacitors, inductors, MOSFETs, etc. These components create a functioning circuit which you can use, which you will use for later, for whatever reason. You have some tools that are essential for soldering. So you have the soldering iron, you have a soldering station, you have ironing tips. So the soldering tips, each tip has a different conductivity level, heat level. So one heats up really fast, one takes time, one is flat. It depends on what you're soldering, and it depends on the delicacy and the sensitivity of your components. So you need to be careful when you're dealing with really sensitive components. You don't want to ruin it, so you want to use something very detailed like this. When you're using something huge, you can use this. Right, so other components, tools, you have helping hands. Not a lot of people like to use that, but it's essential sometimes, so it depends on what you can and can't do. This is the solder. You use lead-free mostly for a lot of properties. And you have a brass and then you have a sponge. The brass is used, after you're done with the solder, because solder accumulates into the soldering tip, so you have to remove it. And the sponge is, you put water on it, so it basically cools down your solder. And I mean, if you burn yourself, just stick your finger in there and hopefully it makes the pain a little bit less horrible. You have a solder scale, right? So, okay, so your soldering scale. Usually when people start soldering, they usually do B, right? Or A. But what we're aiming for is something like this. But for beginners, everyone does this. I did this in LASP. It's not wrong, but it's too much solder. It's way too much, and it accumulates, and it looks ugly, and it's This one, can someone tell me what the problem with this is? Like, it's not connected to the board. So this is creating like an open circuit. This is the same as this open circuit. This is a short circuit. So, when you connect, it just explodes in your face and nothing gets conducted. It's just there. So you want to aim for B, or if you're a beginner, I expect you to do this, maybe even worse. If you're an expert, I expect you to do that. I'm not an expert. I will do this and worse, maybe even. Now, let's say that you actually messed up your solder. What do? You desolder. How do you desolder? Yeah. Yeah, if you don't have the, what do? Yeah. Okay. What? Okay. So the tape, not tape. It's like a copper tape thing. Yeah, you have like a copper thing. You just remove it. Or back at LASP, I was required to change it from this to that. Let's take a closer look at the atrocity what we have right here. A sphere. What?
How long does something like that take to do?
Right, so I'll tell you. I'm going to open my trauma with you guys. So back at LASP, the communications port, this is at the back of the communications port that you just saw. This is what's at the back, right? I had to change it from this to something a bit more specific based on certain specifications that we had to set out, right? So we had to read the circuit, make sure that everything is connected. So changing this from this to that, first time, it took me literally 4-6 hours. First time.
Do you do it in one shot?
Yes. Okay. I did this in one shot. But here's where the trauma comes in. Shatha did a really good job here. I'm Shatha. So they were like, great, you're responsible for soldering the other communication ports of the other flat sats, because the other flat sats also had the same issue. So the other communications ports, actually with practice, it took me 30 minutes each later. So the first time it was 6 hours because here's the thing, this looks huge because the picture is huge, right? The actual one is tiny. I had to use like a magnifying glass and everything. You have to see. The pins are so tiny. Everything is crammed up here. So it takes time to navigate where you want to put it, right? But here's the crazier part. It's not only soldering. The desoldering process was so bad because at a NASA-funded lab, they didn't have the vacuum thing that sucks the solder out. And I couldn't find the copper tape. So the genius that I am had to literally scoop out the solder using the soldering iron. So I had to melt it, scoop it out, and take it out. So that's why it took me 5 to 6 hours. But I did it because I'm that much of a genius. Thank you. Yes. Thank you. Appreciate it. You know. Okay, great. Right, so that's me. I was crying here actually before I filmed, but like, moving on. That's what I was doing, and that's what I did basically. So you can see the clumps. You see the clumps? This took 6 hours. I'm proud, but it took 6 hours to do that. But look how God. It's so bad, but it works, and we were able to get telemetry. So I don't care if it's clumpy. Right. So now let's start your fun activity. Right. Take a picture if you want, because I want you guys to connect this with me. I don't want you to keep looking up and down when you're working. So if you want, I want to take a picture of it. This is going to be the circuit we're going to do, because not a lot here are electrical engineers, mostly mechanical and computer. So I'm just going to explain the circuit. So we have a tiny little light bulb. We have a resistor here, and we have a button, right? We have 2 wires, and we have a battery, right? So can you tell me what this does? Okay, great. So we're gonna solder a circuit that when you click that button, the light will turn on. Fun? Yeah. Right. So I want you guys to, okay. One thing to understand, what you guys have, I'll turn it on. I'll turn the lights on. You take a picture? Yeah. Okay. So I want you to understand one thing. What you guys have, the green proto board, this is called a universal PCB board, right? Universal as in, whatever, if I may, please use yours. Awesome. So if you go horizontal or vertical, this is considered a node or 1 point. So when you're soldering more than one component, if you solder them next to each other, it's like you're soldering them on the same point. The good thing about this is, like, whether you go horizontal or vertical, is Ahmed Hindawi here? Engineer Ahmed Hindawi, everyone. He's my colleague from electrical engineering. Thank you for being here. Awesome. He's going to help us today with this. So you can connect it however you like, right? But if I were you, I'd do it like this, and I start connecting, like the picture. It's easier to follow up with the picture, right? Okay, so let's just start. Let me explain something to you about the LED lights, right? I'll just take that one again, sorry. Hi. Okay, so the LED lights, you have an LED right? So you have, if you feel it, if you feel the rim of the red on top, if you feel the rim, you will feel that there's a flat side, right? Yeah. Right? Do you have a flat side? Yeah? This is the negative. So when you're connecting your circuit together, I need the negative to be with the resistor on the same node, right? So the negative will be here, and you will connect it here, right? So you're going to put the flat side in your PCB board. You're going to put the resistor here so that they're together, right? Does anyone not know where the negative is? Anyone? Don't be shy.
No.
Do you know where it is? Yeah, you don't have a rim. I can see it min bayt. I can. Huh?
Long and short.
شوفي, here's the thing. People will tell you long and short, but I like flat and bumpy because it's easier. Because you get confused. Flat is negative. So this is yes. You can feel the flat side. Does anyone not know? Do you feel it? Do you feel it? Yes. Does anyone not know where theirs is? Do you see it? Do you feel it? Do you feel it? You don't have a rim? You do. You do. This is your flat side. You can feel it. This one. Okay. Does anyone not feel their flat side? Okay. Do you feel it? Yeah? Okay, so when you're connecting your circuit, I need you, yeah.
The negative side tastes different to the positive side.
Yes, yes.
That's a way for people to test.
What?
The negative side tastes different.
Okay, yeah. Yeah, so now, by the way, I'm my mind is fuzzy, so I didn't get the joke, but I'll get back to you on that. Right, so I need you to connect the circuit based on that. So you put the LED, put it in, you put it in, make sure that the wire comes out from the other side, right? It's like a puzzle. So you put it in, right? And then you grab your resistor. Resistors don't have sides. So your resistor is like this. You might want to like bend the sides. Yeah, and you want to put it in. Now the end or the wire that's coordinating with the LED, نصيحة يعني, my advice, twist it with the LED. So you want to like put it in there, if I may. Yes, I'll use you as an example. If I may. Where's your negative side? This one? Great. So we're going to put it here. We're going to put it here. Right? And when you want to turn it over, and you want to see where are they both, like هم اثنينهم وين, it's هذيل النود. These two are together. هذا الريزستور هذا LED. You want to like rotate it كذي على بعض عشان when you solder it's like they're connected together. Okay. عشان يكون أسهل عليك when you're soldering. Like this. Okay? Does anyone have a problem?
Is the resistor wire meant to be touching the circle with the light?
Yeah. If I may.
this?
Yeah, you got your LED way in. Way too in. Well, like yeah. No. The LED lights should not be connected together.
I was just doing
Yeah.
the whole
This is your flat side. Yeah, you might wanna. So this is the resistor one. This is the LED one. You want to toast those together.
Oh, okay.
Yeah. This one, just let it go from the side. It's fine. And this one, the other side of the LED, you can put it here.
Okay.
You can
And
get
it
it.
doesn't matter which orientation the resistor's in?
Yeah. Resistors do not have orientations because it's the job of a resistor is like to make things explode.
Okay.
Sorry, I bent your resistor. We'll just go. Let's go like that and like that.
Reliving past traumas.
Thank you. Welcome. Does anyone have a problem? تعجبيني انتي.
I have a question. Should I take them? ولو أوايد لا كتب على بعض.
Yeah, you can بعد تعفسيها لأنه when you solder I don't want like ما أبي تغزين نفسك.
Wow. I think mine is good.
انتي I know you're gonna be good. It's
As a flat وهذا.
Oh, you don't have a rim. يا حليلك, you don't have a rim. Then why didn't you tell me? Just give me. Hold on, let me see. Yeah, you're good. You're good. Yes. The wires مو الحين عشان I want you to solder properly. هبة, can I have a light with a rim? هلا. إيه خلصنا إيه مو مشكلة. إيه خير. شوف.
What's the light with the rim?
Oh, a light with a rim. Oh, right with a rim. إيش فيك يبا؟
What's it? كلهم right.
لا مو كلهم لأن في من دون رم.
Short and long.
يا عمي انتوا ايش فيكم؟ I think like this. Why is everyone mad about how I think?
قولي short and long.
Here's one with the flat. لا دقيقة. Ahmed Hindawi is like starting because it's his way of thinking. Right. So you put the button. You can put the button now. You can put the button in coordinates with the other leg of the resistor. Right? Does anybody need help? You put it in there, yeah? And then you have wires. So you want to put your wire. Hi guys, excuse me. I'm not done explaining and I need it to be quiet. Huh? No. Excuse me. Okay. So عشان people, not everyone is following up, so I need to. So you have a wire, you want to connect it with the positive leg of your LED. You want to like twist it if you want to. And the negative wire, you can put it in the same node of the other side of the button. like the picture that you have. You still didn't solder yet. I'm just trying to make you make the connection so it's easier for you to solder later. It's like you're melting chocolate on like on a cupcake or something. Right. 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 Okay. شغلته شنو? You guys are soldering already?
لا لا بس حق الاعلام.
Okay.
بس عجي 400 ديجري 400 ديجري.
لا ما راح يجي سبيل.
Okay. You did great.
اول شيء
ايش في تشيبه؟
لا ما ابي
Did I do it right?
Yes.
I'm gonna do mine like this. Should I نسيت كان في فرق this way or that way?
No. LED.
I've never used the button. Use button.
No, it's not. ما في.
يعني اقدر شوفي
Yes.
اقدر الفها كذي.
Yes.
ما
Yes.
تفرق هالنود.
No. Supposedly لا. You're good.
Where are you putting this next to it? This one.
This one, the same node as this. So when you're gonna solder, you're gonna solder this and this.
And which one?
This and this.
Okay.
Yes.
And this one, do I solder it to the positive?
Yes, you solder this. You solder this to the chitty.
That's the negative. That's the negative.
ليش زين؟
Hey, but what's the circuit?
I supervise.
Supervise more.
For what? She wants to put the LEDs next to each other.
بس السؤال
To the positive. Okay. To the yeah. Okay. Yeah. Okay. Yes. It's good.
Okay.
Yes.
Cool.
Okay. Yes. Okay. Let me just double check on you guys. You guys done? Okay.
I don't know if it's right. I think it's right.
Fuck me. Yeah, you're good. You're good.
That was wrong.
Let me tell you why in a minute, because sometimes this button, the orientation, when it's like the closest, let me just show you. You see, there's like too close to each other and too far. If you do the close ones, it's gonna work when you turn it on. If you twist it, it's gonna turn when you don't push it.
Okay.
Because this is a push button, so it's weird. I don't know.
The connections, I put them in the circles next to each other.
Yeah, you're good. All good. Right. So all you have to do now is solder, which is that's where the fun part is. So you have a problem? Oh, you're actually you're good. You're good. Really good. Yes. So I need you عشان لما تسوي soldering. في 100 button. Don't worry about it. هذيلا the fun part in it's here we go. Here we go. You have a button عندك ليتي هني وعندك
من LED صح؟
Yes. وايد مدخل LED. أنا مو شايفة أنت وين. Wow. Okay, that one. Okay, here we go. There we go. So now all you have to do is solder. Well, after the soldering station is done, because it's full, right? Did everyone build their circuit? Yes or no? Does anybody need help in building the circuit? Right. Since you're here, guys, you three. Zingo Ringo, Teletubbies. Keep it quiet. Right. Okay, so.
هو عدل بس مو
يا شنو؟
انا احس انه هو مو مسوي عدل
انت علمين انت ما ادري.
مو راضية تعلمني.
Right. I'm gonna. يلا شلون؟ Okay, you're excited. I'll start with you guys. Yes.
Button orientation.
Yeah, button orientation. Yeah, this is your circuit. شنو هذا؟ هي كذي أنت مسويها ولا؟
No, horizontal.
كذي؟
Yes.
I have no idea. You know who knows about circuits better than me?
No.
Ahmed Hindawi.
That's the continuation of the button.
So I'm gonna assume that you're doing this, صح? I'm gonna assume that this is how you did it. Technically, you're correct. technically. I don't know yet. Right. Right. So, what you have, is it on?
You're gonna get burned. It's on.
Turn it off. Yeah, you can turn it off. It's for safety reasons. How do I check that it's on?
تعالوا هذول شغالين هنا.
شغلتيه توا؟ توا. Yeah, it's not even hot. I can't feel that. عطى كم دقيقة.
بس شيء
We can check by melting solder.
ولا بدونه.
توا. Just give it a few minutes, yeah? تبي can I have a brass? Brass. Hi, me, please. Thank you. هذه يعني تلمعها, you know? So it's good. There, good. It's good. This needs. There we go. There we go. That's it. See. You see the smoke. It's where it's working. It's fine. It just needs. It needs more. But just give it a few minutes, I guess. I'd تقدر, you know.
You solder straight to the battery?
No. You solder straight to this. So you need a helping hand. You can remove these, by the way. آخر شيء مو مشكلة. I need you to connect.
بعدين بالنص بينهم.
Interesting.
بعدين بالنص بينهم.
I didn't see your circuit. What did you do? Okay, let me. خنشوف. لا, I'm just following up with what you did. It's the flat one. حطيتها هني. So you're gonna solder these two together. Okay. I twisting it عشان تعرف أنت where you want to solder. So you're gonna put solder here. على هذه. And then you're gonna put solder.
Not on the board itself?
No, on the wires itself. And then you're gonna solder.
لا هدتني مشى ما يصير.
And then you're gonna.
أنا هديتك.
And then you're gonna solder this with the button metal, right? عشان تربطهم مع بعض.
So they're not connected.
Yeah.
Are they connected like breadboard?
Yeah.
Okay.
بس عشان you solder it عشان يعني إنه تأكد إنه كنا صمغ. Basically. Okay.
سؤال أنا عندي سؤال. How can you get burned? Doesn't look like.
You wanna try?
تبي تجربين؟ حياة ساعة تفضل. 400.
Right. So whoever finishes, let me know because the other people they want to solder as well. So they're waiting for you.
This type of surfboard, you have to connect the legs together.
No. I do it عشان تعرف أنت where you're soldering.
So you fold them in the direction you want to solder.
على الخبير وقعت.
علي, what is this? Okay. علي, ليش كذي السيركت مالتك? Aren't you like an electrical engineer?
No.
What is this?
But I've never soldered on this type of surfboard.
إيه مو مشكلة. Put solder here. Between يعني مع بعض.
أنت بتقومني من الكرسي.
ممكن تقوم من الكرسي يلا في وراك ناس وايد تبي تخلص. ايه ناطرينكم مو اساس الكون. ها؟
بلاير؟ كمل.
ليش تبين بلاير؟ So you're gonna solder these two together, right? And you're gonna solder this one مع هذه عشان هذه the metal of the button coordinating with this one. Go for it. Right. لا please never ever do that. Okay.
It's not working.
You scared me. Wallah. Okay, do you know how nasty a solder burn is? مو حارة. Okay, then this one doesn't work. Okay. هو اللاب عندهم نقص solder soldering iron. Okay.
في زوم ان هذا.
لا I need let me tell you what I need. ايه مو مشكلة. زهراء بس دقيقة. دقيقة.
كل هذا عشان يصوروني ما صوروني.
أنا صورت.
This one's working.
وريني. الحين أطالع الحين زوم. يلا. أطالع عدل.
Okay, منو؟ خلج. No. Stay. I'm coming to you. It's okay. If it's not, then the solder is like messed up and you need to find another soldering iron. But again, it's already cranked up to the highest. بس هاي بنات بس وخرة شوي دقيقة أعطيكم this soldering machine. That's actually good. So I need you. Excuse me.
No, it's fine.
Okay, this is hot, so yalla. Don't try it. تعالي. See, this is so hot.
أنا بالنسبة لي على فأنا gonna show them the demo.
Yes, okay, you do that.
الشغل دق يلا في دور
جماعة, you know what? No. This solder, it takes time to get. So I think I want to get you another type of solder. Girl, it is so hot. You're not wrong. لا, it shouldn't. It should على طول crank up to like.
Yeah, this one's done.
It's not raising up. Muhammad, this one's not raising above 100.
لازم توصلينه
صدق بهذه
اي على شيل الاوتبوت مالها
170
بس if they're twisted there's
100
واصل 100 واط الوات كم
100 watts
يعني put it
عندك الفتحات
خاصك امسكه من هنا why solder them like this
You want to try the other ones? يعني في 3 ports ف
It's 0 watts.
That's more effort.
دوسي على اللي فوق طق. بس click once.
طيب once.
لا click once الحين once.
Okay. Hey.
Bronze.
Yeah, there we go. There we go. Yeah. There you go. Yeah. But you might want to like hurry up, and the other teams are still waiting, and I want everyone to have the chance to solder. Right? Can you guys hurry up?
This is not working.
It's not working.
Hold the soldering iron.
You need to restart.
This needs a USB-C. Technically, I need. Okay, what time is it?
It is 7:30.
Ooh, okay.
صح شوفي
ما بيأخر الناس. خلصت جربت.
حبيبي 400
ليش ما تسوي خلاص لا روح بيتنا
اعتقد خلصت
والله استعبط ما ايش فيك دقيقة يعني زهراء مسكين قاعدين مسكين قاعدين
عادي احنا راح نسوي حق
خلصتي؟ Okay, then you basically do positive side مفروض negative side إن شاء الله تضبط قولوا بسم الله
ما ضبطت
أنتم موصلينها غلط
نتفة
غلط لان على الخبير وقعت
شو مسويين؟
ما سويت شيء انا اللي قالت لي اياه انا سويته
خلاص أعطيك الحين واحدة موصولة وجاهزة ومسوية
وانه يعني انت سويتها ترى مو بالروضه انا
اوكي وانت بالروضة امسك
مشكلة على البريد بورد
بقطع الامير زي يصير
اي مو مشكلة
ولا هذه
اي واحدة
هذه البطارية مو واصلة اصلا
انت ما قلتي لي الحين
يلا استانس يلا وها.
I don't want to connect it. I just want to melt
It's okay. Ayub, it's not melting. You might want to come here and تكفى.
شلون
You might want to come here and.
ولا العكس؟
لا هذه positive negative. البوزيتيف على الأحمر ونيجاتيف إي بعدين.
لازم.
Please do come here and.
ترى لو جايبين بطاط وموصلينه فيه كان. واحد يعني ما سوى شيء.
ما بيأخر الناس.
تفضل أيوب تفضل. تفضل.
ها حصة. Yeah, I will.
Okay.
ما ادري ايش قاعد اسوي.
انا احس انه ما ادري.
قاعد تشوفين I did like 3.
Okay, so what's your problem, Engs?
ما ادري is it okay?
So if it doesn't work, I have circuits ready made. You can just grab one.
Sure.
Okay? Hold on.
You came prepared.
Yeah. For worst case scenario. لا هذه الأسود هذه.
عبالي النملة.
لا. Right. So. أنت الحين. I don't know how you're soldering. You did. What do you do? What did you do? Okay, where's your resistor?
I think I got.
How do you resistor? Okay, this. Okay. فهمت. آخر مرة قلت لهم لا حد يحرق نفسه، أنا حرقت نفسي. I need you to
You need to be شو اسمه role model عرفت؟
Yes. Technically.
بس.
I need. This and this to be connected together. فأنتي the more solder you add. خربانة بس إنه.
هذا وين شلون اركب الدزام؟
So you have like one of the. I'm sorry, and you have one of the worst solders.
Oh,
لا, not you. The soldering iron is so bad.
Okay, it's fine.
Not you.
أنا اللي قاعد أعامل كلكم يعني أنتوا you know what you're doing بس إنه.
I know what I'm doing with
It's not doing.
It's not doing. خلاص جربتي؟ أعطيك واحدة خالصة for the sake of time. I know. انتي روحي مكان ثاني احسن لك.
ليش؟
مو مشكلة. تبين تاخذين واحدة ذهبة؟ No, this is so bad. I need to.
بس أوكي.
خلصتها؟ You guys like. Okay, which one's working? Hindawi, you're working. This one's working. Mirza, is it working with you? Sometimes. Okay, I need. خايس. تعالي حصة. Let me give you واحدة. No, I'm gonna assume that it's not because it's not heating up properly. Okay. Okay.
Yes.
I need. Okay. Muhammad, I need a. Please, I need another USB-C to USB-C.
شنو تبي USB-C؟
To USB-C.
عندي واحد
They're brother and sister, by the way.
رده مكانه. دقيقة يرزا رده.
You need a band-aid? Seriously? You burnt yourself? You get the unicorn band-aid.
هذا خفيف استخدمه. بسرعة راح هذا اللي عندك كبير.
Here you go. Okay, guys, we need to like شوية crank it up. Then I don't want to waste anyone's time, and it's gonna be 8. Here you go. Very mature band-aid. Halah. We have our first injury. Yay!
راح يشتغل.
It's here.
بالعرض بالطول.
I should have let the doctor do it.
Shatha, the other way.
Switch, and then I'm gonna open my fingers.
Yeah, you're gonna open both, but the other way, your whole knuckles is just gonna.
خلصون البوينتر اعطيه حق
اوكي يعطيك العافية علي.
وايرات البطارية.
Forget the battery, it's fine. Later.
حلو
انت شفتي
سهلا حياك لقينا
انت شفتي السيركت مال علي؟
هذا شنو يسوي؟
شفتي السيركت مالت علي؟ ريلتش.
اي
هذه. اوكي so you're basing it on it؟
هذه السيركت مالتي.
لا اشتغلت
بس بعدين هذا صار لوز ما ادري.
اي بس عرفت
مو لاحم عدل.
اي بس عرفتي شلون تلحمين صح؟
لا عارفه الحين شنو؟
نلحم كذي صح؟
يس. انت الحين تلحم الواير مو مشكله شيل الواير حط الثاني. اي صح صح اتس جود.
اللمبه
لا اتس جود هلا
هذا مو ملحوم.
ثانك يو.
شنو مو ملحوم؟
اي مو مشكله الحين بلحمه الحين الحين نبي الحمه.
We're reserving material.
You're good. Okay.
شيء مسهل على روحك.
الحم هذه. This point. Yes. Okay. I need. Okay زهراء روحي السايد الثاني. أبي الريايل اللي هناك they start soldering. تعال.
الحين بخش.
Yeah, in a minute. Just give me a minute. Please have a seat. And I need you to be careful, yeah?
Step by step.
You know?
I thought you step by step, please.
In a minute, yeah. من عيوني. Right.
هو اللي حرقت صح؟
هذا آخر شيء. Okay, then I need you to focus على هذه. You see this? اللي we twisted? I need you to melt solder on it.
عليه؟
Yeah.
مو على البور؟
No, it's fine. لأن this is أصلا تشتغل حتى لو. The fun about it's fine. You have more solder all around. The thinner one? Yeah. Can we have some, please?
Shatha.
Give me. Here, this. This is better. Yes. Yay! Enjoy. Okay, please do. And send it to me, yeah? Teamwork. Yay. Yalla, take it with you. Okay, so you melt. Yes. Yeah. Yeah, actually very good. شوف انت جامعة الكويت. You can pass by the lab anytime to keep practicing on the solder, but for the sake of time عشان يعني I don't want you to waste your time. You can do. So this is your circuit.
في شيء غلط.
هذه the other side. Oh, it would work. Sorry أيوب بس تسمعي. Right. I need you to. I need this. Oh, it's fine. The good thing about the pins Adela, you can bend them and do whatever you like. Here we go. يلا مشان الله. One. Okay, fine. There we go. 1, 2. Okay. Now I need you to solder. This point right. Okay, I need you to put solder. You see this wire? You see this point? I need you to put solder between them, honey. Okay.
So the last one here?
Yeah, where's your wire, if I may? Right. Let me just take a look.
Where do I do it? The same exact thing.
Here.
Yes, just add more.
Alright.
Okay, so this one will go on this pin. Just pin it. Just put solder. Right, just put it between them. Right.
ايش قاعد يصير؟
انت when you want it's okay.
This one with what?
So when you're doing this, I need you to
Those are my wires.
okay.
I took them out.
Right. When you're doing this, right? If I may, okay. You want to melt the solder, okay?
Okay.
And then put it. It's like you have sauce and you want to put it.
هو يجي عليه.
Yes. So you want to melt this and put it here, right? This is the easiest way for you, and this solder it can stick to this.
Okay.
If you put it chili, you're burning your proto board. If you put it here, you're burning it. No, I need you to put solder and spread it. Okay. Okay. So now, hold this. Now I need 2 wires. Okay. Let's pretend, right? So you have Hadi. I need you to solder. قربها شوي. I need you to solder these 2 together. Okay. I need you to solder these 2 together. Okay. Yeah.
I know what I'm doing. That's right.
You want to stick them together. You can drop this when you have some in your hada عادي. You want to hold the wire. Hold this wire. وحطهم يعني قربهم مع بعض وصادر. Okay. يا عيوني. شوفي انت معنا انت your KU as well. You can come in the lab anytime and start soldering. She's fine. You can come in anytime. By the way, I'm so sorry you still didn't solder yet.
It's okay.
Oh no, you're fine. I'm talking about these 2. You're fine. You can pass by anytime. You're a university student. You can.
Is this whole kind of campus new?
Yeah.
It's so flashy. I didn't know we had this in Kuwait.
Yeah. Kuwait University.
We moved here 20.
We moved here 2020.